Hello, everyone. Good morning. Welcome to the Kubeflow on GCP session. I'm Kanchana Patlola. I have, for the past 5 years, I have worked as an AI specialist in one of the major cloud providers. I've worked with FSI, retail, HCM, cloud native companies on their quest of AI innovation in cloud. One of the major challenges I see working with a varied set of customers is most often the teams are well aligned. They know how to create, they know how to build, deploy models, the train, monitoring. However, the challenge they face is when they have to deploy things in scale. Earlier in the session, we discussed MLOps, which essentially comprises of CI, CD, CT, CM. Kubeflow pipelines is necessarily a tool which helps the machine learning workloads play a crucial part in MLOps. In this course, we'll talk through a notebook with Kubeflow deployments and highlight how the architecture creates a unique ML workflow. As prerequisites, though the notebook itself is self-explanatory, to be successful in this session, you would need a 100-level understanding of Kubernetes, MLOps, Kubeflow, etc., and a working knowledge in Google Cloud Platform, particularly with respect to deploying notebooks, service account creation, BigQuery, data flow. You should be able to read, execute, modify using Python programming and TensorFlow modeling. Audience for this session, this will be most impactful for MLOps engineers or data engineers. But if some DevOps engineers or data scientists are interested, I highly recommend them taking the session as well. First, we'll start with a walkthrough of a notebook, which will be about 3 minutes, and I'll cover the next steps in a minute. So let's move on to the demo piece of it, and then we'll start with the session. Okay, now we are in the demo. If you're starting newly, I highly recommend you enable the Notebooks API and the Vertex AI enable in the console. And I have created a user-managed notebook in this session with TensorFlow 2.9. For this demo purpose, it doesn't matter where you create the notebook, how you deploy it. In this demo, I'm going to showcase how Kubeflow pipelines would work with multiple products in GCP. However, bear in mind that Kubeflow by itself is cloud agnostic and can be deployed in AWS, Azure, OpenShift, etc. We'll see what is a custom component and how existing components can be built and leveraged. I will share the GitHub link in the description. Please clone the Git repository. Once you clone it, you should be able to see all the components. And we are going to be working with Google Cloud Pipeline components with BQML as in for text is the notebook. There are other useful notebooks in the repository, as you could see here. If you'd like to play around, I'm running the notebook with the Python kernel, and you would be able to see it. So first off, you would need to update the project ID and the bucket name when you're running the notebook. As you go through, you would see it. I have already run the pipeline due to time constraints. I'll walk through how that pipeline is created and executed for ML workloads with this demo. We'll skip the installation pieces of it, the BigQuery pieces, again, due to time restrictions, but that should be pretty self-explanatory. If you have any issues, please reach out to me. First, what is a pipeline? A pipeline is a set of components built together to generate an ML workflow. And it can be a custom component or a built-in existing template component, which is what we'll showcase on today. This pipeline, as you could see, it's a Reuters pre-processed job name, and it has some BigQuery interaction, as you could see here. And I will showcase how this visualizes when we go to the next step. But to start with, you could see that there are some components which are built here. And essentially, a component gives the detailed information of what that job does. When you're creating a pipeline, you would essentially bring all the components together. So for this instance, this build data flow orgs uses data flow Python job op, which is an operator, and builds that custom component. Whereas the pipeline also contains other pre-built ones, which you could see here: BigQuery, create model, job, etc. And it stitches all of it together in a pipeline. And as you could see here, once the pipeline is written and built, you compile it. And once the compilation is done, that's when you execute a pipeline job. When you execute the pipeline, that's when your next screen comes, which is essentially giving a visualization UI for how the pipeline is going to look like. As you could see here, remember the build data flow aux? This is a custom op which we created. And there are other specific ops you could see here. One thing to note here before we move to the next steps: what is a component? I'm sure you probably have have an idea of what a component is. Components are essentially which has input, output, and it has an implementation layer in it. Each of these components, as you could see here, can by itself be a container, or it could be a component which you have built. And if you have used Airflow, one of the prime differentiators here is that here you can pass the data between the components, whereas in Airflow you need to have a dependency graph, things like that. In the completed demo, as you could see in the visual representation, this is the BigQuery job. And as you could see here, there are some input parameters and output, which is clearly detailing what that pipeline does. But these are the things which are interesting because it shows, for instance, in this one, it does show what it is, what are the inputs it takes, what are the job name, what is the output. And some of it are pretty good. Like if you look at it, it clearly showcases all the things it does in this pipeline. And when you go inside a little bit, so in this one, they're training a model in the code itself. And then they would do a predict statement. So you could see a create model job. In this, essentially, they're creating a model, as you could see here, from a table, and they're training it. And once that's done, as you could see here, it stores the destination table information in here. And then it does evaluate. And you could see here, a model was created, and it was stored in Google Cloud Storage. Once that's done, in BigQuery, they're doing an evaluation, and it's used for prediction again. So in this case, all of the information which is needed for an big ML workflow essentially is drafted here in one view. You would be able to restart as it's needed. And if a job gets stuck in a component, you would be able to bring it back up and execute just that component instead of starting from the first. And that is why this makes it more unique. Again, as I said, I would recommend you experimenting with the other notebooks in that repository. And if there are any questions, feel free to reach out to me. With respect to the next steps, experiments with other notebooks. And I also would highly recommend you to experiment with other cloud providers because there are some published AWS, Azure, OpenShift notebooks out there. I would recommend you use that. And also check for external components. If you are a Kubernetes expert, you could probably look at how Istio can be used, how Fairing could be used, and other things which can be used. Thank you for listening to me. I sincerely appreciate your time, and I'm looking forward to working with you more and more.